No questions? Let me put the chat here so I can always see if you have any questions. I have like 2 more weeks of school. Yeah, we only have 2 more weeks of school. So basically, they okay, I'll show you. The last level report is due soon. It's not like the Tuesday. The Tuesday. Okay. Let's see. So let's see. Let's look at this one. Can I see the map? Okay. So okay, we just look at this one. So this one is a 6, 4, 5, 6. So by the end, I think this lab report is due on Friday. If you can submit, maybe I can extend to Saturday. You submit it on Saturday. So I think the next Monday I will report compile all the grade to the department, so they can have your grade and you can see your grade for physics in your Blackboard or CUNY first. I think, yeah, I want to have 1 day's grace period to grade the last lab report and then compile and then summarize all the report because I have 2 classes. So I have another lab. So we're gonna do on Monday I have to submit to the department. I guess the last day of this, if I don't remember wrong, I think this Sunday. But I think on the syllabus the last day was 28th. Maybe the department will extend to the 31st. So you can still have plenty of time. I think, okay, I think if the last day for the class is 28th, so maybe so you can still submit the lab report on 27th. I guess, okay, maybe you don't have to rush your lab report. You can still submit 27th for the last one. Okay. I'll let you know when I get more information about the last lab report, the due date. So today we have lab 4. I hope you already review all the lab reports, all the lab manuals by yourself. So today we have 2 lab sessions. The first part is, so you will do by yourself. The first part, you don't need to write any lab report. You don't have to write anything. Basically show me your certificate. That'll be all. So, but you have to do the work to get your certificate. Basically, let's say this is the circular motion lab. So you click this one. Basically, in this lab, you follow the instructions from the screen. Okay, you follow the instructions from the screen. You follow instructions from screen, and then you can learn. So for example, the first one is revolution per minute. So what is revolution per minute? It simply measures the number of times of an object go around for a circle in 1 minute. So okay. I don't know what's wrong. Okay. I don't know. My computer is kind of slow. Right. Because I opened too many accounts and stuff. Okay, anyways, we can start from this one. Yeah, I want to do this. So you click the grid and begin. So basically, after you know what is revolution per minute, so you can count for the revolution per minute. So let's say, so now it's like a 12, 3, 6, 9 clock. You just pick one, then you count, let's say when the ball crosses one, we start counting. So you click here and then it starts timing, right? Okay. Okay. So reset. Okay, let's say when it crosses here, we can start time. So you click the start timer, then you start count. 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So basically you count and then you put number here. So this is what you do. Yeah. I guess. So you in total you have eight exercise here. So after you finish them, they will ask you to do then input your name and your name. So in the end, you will be request to enter your name and the date, and the time of the completion of 80 rows of result will appear on your certificate. You just take a screenshot of your certificate. This is for the lab, the part 1 of your lab. So let's say, okay. So you just use the timer. Use the timer to count how many circles, because this is a revolution per minute, and I put it here. Then you count, and then then they will go to next page to finish the total 8 rows of the experiments. Okay, so this is the first one. The second one is for circular motion. You can see here. So let's see. So we can see here, you have an object, you have a string that connect to this object on the net. And the string, at the end of the string, there's a force probe. So this is a heavy atom that hold this string and make this ball kind of rotating. So let's begin. So basically, we still do circular force lab. Here are 3 variables. One is mass. You can always change the mass, and the speed randomizer, so it generates a random speed. Then a radius, so you can click up and down, so to adjust the radius. So in this lab, we're gonna do 3 experiments because we have 3 variables. We want to do like each time for example, the first one, vary moving mass. So basically, we keep the speed and the radius are always the same, and we do the mass as a variable and check what's the relationship between the centripetal force and the mass. Okay, so let's begin. So we start with the mass of 0.5 kilogram. Slower, 0.5. 0.5 kilogram, and the maximum radius to 2 meters. And the speed we keep constant. So still random speed is 1, right? So we keep this 2 constant, then we can start. You see here, this is the same thing. You see the ball is rotating here. Once you click start, you see there's a this called the force probe. So this one, basically the centripetal force that moving this ball is equals to this force probe, but still we still need to calculate. So what we're gonna calculate is so you have a table here. It's very slow. My computer is super slow. So right now we have a radius at 2 and the rotating speed. The rotating speed you can calculate by this equation. So you're gonna use 2 pi r over t average. You don't know what is t average. So don't worry, we can get the t average here. So the moving mass is start from the smallest moving mass, which is 0.5 kilogram. And each time you click one upward arrow and to increase the mass, but it keeps the radius and the speed the same. So so when you do the when you count it for the periodic time, so this is periodic time. So you count from so like let's say when it crosses this one, the 3 o'clock one, then we start timing. So we time for 20 circles, 20 counts, and we use this time. Let's say it's 20 seconds, and 20 seconds divided by 20, it's 1 second. So the periodic time will be 1. So you take, this is the first trial, and then you will do a second trial and take, record the T2, and take average of T1, T2, and put it here. Then you can use V equal to 2 pi r over T average to calculate the randomize the speed. And you see here, you can, force probe is recorded through this box. So you can just record the number in this box. And the force, the centripetal force is calculated by, centripetal force is mv equals to mv squared over r. So after you calculate this one, you can calculate, after you calculate the speed, you can use mv squared over r. R is here, right? You calculate the force. Or there's another way to calculate centripetal force, which is you, because we know v squared equal to r squared omega squared. And then we know omega equal to 2 pi over t. Okay, see, omega equal to 2 pi over t. So if we want to do, let me write something here. It's very slow. Okay. Fc equal to mv squared over r. Oops, let's do that. So slow. Oh my god, I cannot change. Okay, now I change. Mv squared over r. So v equal to v equal to r omega. So equal to mv equal to r omega squared over r. And it equals to, omega equals to 2 pi over t, right? So r squared, And omega square. Omega square, we use 2 pi over t. 2 pi over t square over r. So you see here divided by r and there 2r, so we can cancel a lot. So mr equals to mr and times 4 because there also another square, right? 2 square pi square 4 pi square over t square. So this is how you get this equation. And you can use this one because you have a pi is a constant, m is a constant, r is constant, you can hear. And you can, t you measure, you can calculate centripetal force. And you do, how many simulations you want? So this is the equation you want to do for the first one, and then you increase the mass to do the rest. Okay. How many? So you will do 7 different. So it will be seven different mass you record in this table, and then you plot a graph of FC versus as a y in a y-axis and versus the mass, moving mass, and then you try to figure out the relationship between these two. What kind of relationship would you expect? Let's see if this equation FC versus m. So if this is y, this is x. So for r for pi square over t square will be the slope. Will be a k because they are all constant. I don't know why it's so loud. Can you hear me? Because I think my background is so loud.
We can hear you just fine.
Okay, thanks. So then you have this one. So basically, yeah, you can record the 13.43. I mean, just changing, but it doesn't matter. So let's see, I still need to draw something. So, okay, draw. Let's see if I have a, see, I already finished this, just start appearing. Let's have it. And then, so this F is FC, M, X is M. And FC. So it will be a linear relationship between FC and M because this one from here to here, this is a constant. It should be like a relationship like this. Okay, let's wait. Yeah, I just give up. I don't use this one. It's too slow. So this is what they ask you. So the graph to determine how the changing rotating mass affects the centripetal force for circular motion. So that means like when the moving mass is increasing because you're gonna increase the moving mass, right? And then you can see the centripetal force is increasing or decrease. Because from the equation we already know it's gonna be increasing. It's like a linear because this is constant. But if you have other values, you also write down, but I don't think you will find something else. Okay, so what can you infer concerning values of rotating masses and centripetal force? So you can infer maybe it's a linear relationship. So next question, for each force probe value recorded in table 1, there is a corresponding centripetal force. Is there any difference between these two recorded values? So one is calculated centripetal force. Another one is the force probe you recorded from the screen. So as I mentioned earlier, these two should be, like, theoretically they should be equal, but not exactly, because we all have errors, right? We have calculation errors. So even here, because the string has a contact with the wet is with the net, so it has friction. That means they will cause some energy. Okay, I don't want to go that deep, but there will be some errors that make this centripetal force different from the force probe you see here. So they ask you, is this possible for these two values to be the same? So tell me what you think, then you can answer this question. And so this is for the first one. And then the next two will be very similar, because this is the first one so you do seven trials. This is the first one. Then you stop. Stop. You see? Stop, then start again. So then you increase the mass to 0.8 to start again, to record the same thing, the periodic time, and calculate the centripetal force put on the second row, and you repeat it for 7 times, and you will get a full table. So you just present, so in this lab, you don't have to present any lab procedures because it's already very clear in the lab menu. So what I want to do is you just present, the first part is your lab certificate. The second one, you will present 3 tables. So this is one and one graph, 3 tables and 3 graphs, and answer the questions below. Okay, so you don't have to write any procedures. If you want to write your conclusion, you can still do that, but don't need to write anything, any procedures. But I do want you show me your procedures about how you calculate the centripetal force. Because either you use this equation, or I said like mv squared over r, the equation. So it both works. I want to know which one you are using and how you get your numbers. This is the only thing I require you to do. So this is the first one. The second one is very radius. So now we're gonna keep changing the radius and keep the moving mass as 1 kilogram. So it's 1 kilogram. The speed is still the same. The radius from the smallest is 0.5. So in this table, you only do you only need to collect 4 data points. So you have this radius, and then you start the experiment. Oh, it's super fast. So you can start timing. Let's say you count for 20. Count for 20 circles. Record the time, and the time divided by 20. That's your periodic time, and put it here. And then do one more time. So then you stop, and then start again to record a second T2. Then take average of the T1 and T2, put the average here. And when you want to do the velocity, the rotating speed, V equal to pi r over T. So you can you can calculate weight, V. And the centripetal force probe is still recorded from the screen. And the centripetal force, you calculate the same thing. The only thing you changed is the radius you changed. So you collect four data set and then make a plot. So FC versus Y, and so that you can determine how change the radius affect the centripetal force. So also you can say from this equation, so what's the relationship between FC and R? So it's still so M is constant, pi is constant, T after you calculate is constant. So you will have then you will have like a close to linear graph with FC and the radius. What effect does changing the radius have on centripetal force? So when the radius is increasing, you can tell if the centripetal force is increasing or it's decreasing. Let me think. Okay, maybe that's not necessarily to be linear. And you can record your data and see if what you can get. But I think it should be linear. Bigger radius. It's supposed, yeah, when you want to maintain the same speed, you have to, when you have a bigger radius, then you have to have a bigger centripetal force. Or it could be decreasing. If let's say if you have a you increase the radius, if you have the same centripetal force, that definitely will make the whole movement slower. But anyways, you just so we don't want you just guess. You can record. You can get conclusions from your lab report, from your data. Right? Data tells you everything. So the third one is changing the speed. So this time we keep the radius and the moving mass. You can see the table. Radius and the moving mass are constant. And then you randomize the speed. So the first one, stop. Okay. So it's 1 and 1. So the first time you use this speed, you record the time, average, do 2 trials, get the average, and then calculate the speed 1. And then calculate the centripetal force and record force probe. This is for the first data set. And then you stop and then go back to change to another speed. So if you click this right button, you click one time, then you have another speed. So this speed, you're gonna do one more time. You start rotating and record the time and calculate the speed. And then you try to do the centripetal force. So after you fill this table, I guess so they want you provide 7 different velocity values. So basically, they only give you 4. You can add 3 more columns, 3 more rows, and fill them all. And then in the end, you make a plot. FC as a y-axis, and the speed will be the x-axis. So you can tell what's kind of the relationship between these two variables. And you can see, so basically from the graph, let's say it's linear, but it's not necessarily to be linear. So if it's linear, they ask you what effect does it cause to the centripetal force because of the speed, right? So if it's linear, I said if it's linear, then when you increase the speed, that means the FC is increasing, right? But also according to the equation here, FC equal to mv squared over r. So I would guess, but you definitely plot your data in the graph and tell me what you found, right? But I think there'll be like a graph like this. But yeah, it doesn't matter either a payload or something is called. So either it's like this one or just part of it. So either, so you can, the y-axis can be here, the y-axis can be here. So it really, the shape of this graph really depends on where the y-axis is. But what you need to do is just plot in the Excel, and then show me the graph and the table and your answer to the questions. So that'll be all for the lab. Any questions so far?
Do you want the questions all the way at the end or right when they pop up on the lab report?
Sorry?
Like, do you want the questions saved for the end that we type all the questions and we answer them? Or if it's maybe like number 9 with the question, should we add it right after we include the chart?
Okay. I understand your questions. Yeah, please type the questions because otherwise I don't know what you are answering. Because like they're pretty much asking the same questions.
And should we type the question though, oh sorry, at the end of the report or right, like for number 9, should I put it right after the chart or should I wait until the
After your graph. Okay, so basically
okay.
the order is like a table, graph, questions, and the next table, next graph, and questions.
Okay, thank you.
Any other questions? So, so pretty much that's all for today. I'll try to erase this. I think I need to restart my computer. But if you have any other questions, you can. I'll just upload the recordings to YouTube, and you can check. Then before you go, then I'll take attendance. Then okay, let's stop recording. It's super slow.